When we first started coming up with the design for the URB-E, we began with rough prototypes and napkin sketches. This was a decent starting point, but quickly became expensive and ineffective. So we turned to SOLIDWORKS, which provides powerful top-down modeling tools to accomplish this task digitally, reducing the need for costly prototypes and saving erasers. For the URB-E design, taking advantage of these tools allowed me to quickly lay out our initial design concepts, verify their function, and easily create the required 3D models for prototype and production. After logging in to SOLIDWORKS Manage, I see our project manager, Brian, has assigned me an urgent task of creating the front fork component that we need prototyped as quickly as possible. Starting out in the layout sketch, I am able to drag the sketch blocks through their range of motion to verify function. To move forward with the front fork design, I'll drag a previously saved sketch block from my design library. Notice how easily it snaps into the proper location. Adding one additional constraint fully defines its position. I want to transition this 2D sketch block to its own individual component where I can create features. And this is accomplished using the make part from block command. This new part can be positioned coincident to the layout sketch or parallel, depending on design intent. In this case, I pick coincident. When saving the new part, SOLIDWORKS PDM automatically assigns a unique part number, saving me the time of looking it up myself. This data card contains the attributes required. Some of these are filled out automatically for me, such as project name, but I need to fill in the description. This is a required input that helps ensure consistency from user to user. Now I'll simply edit the part and extrude the sketch. Here's a pro tip. With the extrude command active, simply select the geometry you want to reference for the end condition, such as the face of the hub shown here. To develop the outside profile of the fork, I'll create a sketch and cut away the outside material. Simply sketch a couple of lines, then dimension to the outside edge and add an angle dimension. With the Cut Extrude command active, right mouse button click, and in the context menu, all of my end conditions are available. No need to navigate back to the property manager. I wasn't sure exactly where I wanted the angled cut, so I'll utilize Instant 3D to drag that angled face to a new position. There, that looks great. At this point, I have the outside shape completed, but I'm going to guess Brian won't like the piece of machined aluminum block. Not to mention, it's not very functional. SOLIDWORKS provides a very powerful tool that allows me to convert the outside faces of this block to a sheet metal part in a matter of minutes. The tool is called Convert to Sheet Metal. I'll select the gauge table, sheet metal gauge, and bend radius, and the faces to convert. Instead of mirroring the individual features, I'll mirror the body. Then, because this is a consumer product, I'll break the corners so there aren't any dangerous, sharp corners someone could get injured on. Adding some branding to this part could be done with a decal, but I'm looking to impress Brian with something a little more. So I'll use sketch blocks again, but this time for a different purpose. I want to use this logo as a boundary for creating perforated holes that will become the logo, right in the sheet metal. After exploding the block into its individual entities, I'll use the Fill Pattern feature. This is a great tool for quickly adding a pattern of features based on any boundary, be it a sketch or even an entire face. Now it's time for prototyping. Typically, a 2D drawing would be created and generate a flat pattern, which could take some extra steps. However, I just want to get the DXF to the shop as soon as possible. Right in the feature tree, I can directly obtain a flat pattern without manually creating a drawing by selecting Export to DXF DWG. I can even modify the output in the preview window to remove any unwanted geometry, such as this logo, as it might be a bit expensive for a simple prototype. Back in the assembly, I want to make sure my new component has the same appearance as the other components. Instead of tracking down the person that added the red color to these other components, I'll use a quick shortcut. In the context toolbar, there's the ability to copy an appearance and then apply it to another component. This allows for a nice, consistent color theme that correctly reflects the final product. Now that I have completed my task, I'll update SOLIDWORKS Manage. I'll adjust the time used, as well as an overall completion percentage. Manage even allows me to attach files to the task. So if Brian wants to review, he can access these files easily without having to come ask me or spend time searching himself. By utilizing the master model approach at the onset of the project, I was able to efficiently create the geometry needed for the front fork component, meeting Brian's strict time constraints. Sketch blocks speed up the layout process, and tools like Convert to Sheet Metal allow you to create complex geometry quickly. SOLIDWORKS Manage can help you track your progress and automatically update your management team's dashboard, providing visibility to the entire project. Keep watching this series to see how URB moved from concept to consumer, leveraging the SOLIDWORKS solution.